Welcome to the Newton tutorial series. I'm Mike Cruz with AC-Tek, and in this tutorial I'm going to give you a basic overview of creating and manipulating clusters in our cluster creator window. So the clusters are the building blocks of your particle set. Your particle set is composed of anywhere between 1 and 50 different clusters. So in our cluster creator window, we have a drop-down menu that allows you to select the current cluster from all the clusters in the current input file. The buttons along the bottom here allow you to create a new cluster, rename this current cluster, or delete the current cluster. Additionally, if you right-click on the combo box itself, you can copy the current cluster to a new cluster. You can move that current cluster up or down in this list, or you can import or export clusters to a DXF or a CSV file. Below our main cluster section here, we have a grid that shows you the individual spheres in each cluster. You have the sphere number, the radius, and the X, Y, and Z position of each sphere. You'll notice that in the rendering window, the current selected sphere is highlighted blue. If I want, I can even change the view to transparent or wireframe for these particles. I'm going to go ahead and turn on the UCS icon as well, because that helps us figure out, well, when you talk about the X, Y, and Z position of the particle, it's tough without a coordinate system to guide you. The number of spheres is listed in this text box here. And then there's a button here to transform the current cluster. You can perform some translation, rotation, or scaling operations on the cluster. We'll talk about that in a bit. Below the cluster grid, there's a window that displays the information about the cluster size, volume, center of gravity, moment of inertia, and also there's a checkbox to lock rotation for this cluster. So what that means is any particle set that you put this cluster into, if the rotation is locked, then in the Newton simulation, Newton will not allow that cluster to rotate in the simulation. And pretty much the only time you ever want to use locked rotation is if you were using only spheres in your particle set. Because a cluster that has any more than a single sphere or any more than two spheres, it can't roll around on its own. It requires some moment to force it to roll around. But if you had a particle set, such as this sphere is only 200, we've got 10% of these particles are the sphere no rotation cluster. The rest of them we allow to rotate, but only 10% of them here are on this this no rotation one that has that locked rotation. But for all your other clusters, don't even bother with the locked rotation. It's just gonna be unnecessary. Below this info window, there's a section that allows you to view your cluster as meshed, and you can change some mesh settings there. I'll talk about that in a little bit as well. So let's go ahead and create a new cluster. I can say new, and there are two options. You can either punch in a cluster name and the number of spheres for the cluster, or you could go to our cluster creator, which allows you to quickly generate a geometric shape. So you specify how many spheres do I want in the X, Y, and Z direction. Let's say 5, 4, and 3. You can specify the spacing of the spheres in the X, Y, and Z directions, and you can specify a tilting angle to slant the cluster. So let's just go ahead and say 5 and 20, 10 and 20. And then to close this, we just close our window, and it'll create that cluster for us. Now you'll notice that it switched us to that new cluster, told us how many spheres are in the cluster now, and we can see each sphere in this list. Now anytime I make a modification to this cluster grid, if I change any of these spheres, to anything else, up here in the top it was updating the cluster, and it's also updating any particle sets that this cluster is attached to. So for example, if I let's go to one of these other common clusters that I know is in a particle set. So we got this nice little 4 cluster, and if I want to go ahead and change the radius for this particle to 200 and change this one, let's just change the Z position let's change the Y position by a couple hundred. So now it's a goofier looking particle, and up here it updated the cluster as well as the other particle set. So if I go back to my particle library and I go to my 40 to 100 set, I can see my cluster right there got automatically updated. and we can see that's this one right here. It's telling me now your new largest sphere radius is 26.4, and it's telling me the overall cluster size. That got automatically updated. What doesn't happen though is if I had generated material using that 40 to 100 particle set, those generated particles will not get updated. So you have to always regenerate your material after you make changes to the clusters or the particle sets. So we go back to our cluster window, and what else would we want to do with this cluster? Maybe we want, let's go to a different cluster. So this is my 25% overlap 4-flat cluster. What we can do is we can open up our transform window and we can change this cluster around a bit. Sometimes when you create clusters and you shift your spheres around, you'll notice that our center of gravity is no longer at the origin. And that used to matter for the purposes of generating material, but we've changed it so it doesn't matter what the center of gravity is anymore. But if you want, you can still zero that center of gravity using this button. And it will again automatically update that cluster and fix all the particle sets. If you want, you can translate the whole cluster in the X, Y, or Z direction. Doesn't really make any difference at all because all it's doing is changing that center of gravity basically. You can rotate the cluster. If I go to switch to a top view, so we're looking in our XY plane, now we could say rotate about the Z-axis by 10 degrees. And we can rotate it about the Y-axis as well. And the neatest function is the ability to scale the cluster. So let's go to yet another one here. Alright, so this is a 35% overlap cluster. Now if I want, I can scale the X, Y, and Z dimensions and the radius. Or I could scale just the X dimension, or just the Y, or just the radius. So if I turn off this radius and scale the entire cluster by 1.2, it's going to scoot all the clusters away from each other in the X, Y, and Z directions, away from the origin. But you'll notice the sphere radii are staying the same. So basically I'm changing this so it's no longer 35% overlap. And particles are actually underlapped now. If I want, I could take and scale the radius a couple of times, and now it's right back to that same 35% overlap. If I want, I can say, well, let's just shrink everything back down here. If I want, I can scale just in the X direction. Let's go back to our top view. So this is going to stretch out these spheres in the X direction and leave everything else alone. We could do the same for the Y. And since this is a flat cluster, we have only one cluster thick. If I try and scale it in the Z, it won't do anything because it's already aligned with the Z axis, with the XY plane. So that's just a neat way to manipulate your clusters. Now, the mesh function is pretty nice as well. Let's switch to our classic 10% overlap 8 cluster. You might recognize this because it's our Newton icon. So what we can do with this mesh function is take each of the spheres and create a cluster mesh that just is a little more visually appealing, might be a little more realistic looking than a series of spheres. You can choose this section right here. All this is basically a preview of the cluster, the preview of what the mesh will look like. So you can do low quality or medium quality. The medium quality just looks a little bit nicer and takes longer to render. You'll notice as I'm sliding this slider, it just takes a little bit longer to update than the low quality. But currently, when you run your simulation and open up the playback file, when you can change the particle mode, the cluster mode, to meshed, but right now Newton is automatically calculating the mesh factor that should be used. We're going to change that so that you can actually go and say, well, I want to change this and actually use my own mesh factor. Maybe I want it to look like this instead of whatever Newton gives me. So that'll be coming up in a future update. And I think that covers everything in this window regarding the cluster creation. Oh, you know what we haven't? Let's talk about the exporting and importing really quick. If I wanted to, let's just make a few changes to this cluster. Let's, scale it a bit. Let's make the radii different sizes. Actually, not that way. Make this 200. Make this 120. We've just changed our cluster a bit. So let's go ahead and export this to a DXF file. We'll call it whatever. I already have something called test. Call it Mike. Now if I go to that folder, where's my DXF? There it is. Open that up in TrueView. You can give me a second to pop that open. There we go. You can see we've exported our cluster to a DXF file. And what it did is it created two layers, circles and spheres, and it exported the spheres onto both of those layers. So when you import a DXF file for a cluster, the spheres can be represented as 3D spheres or as circles. So now if I go back, let's close that and import that cluster. Import, which one was it? Mike. And import it, we'll call it whatever. It imported that same cluster again, and it switched us right to that cluster. And one other thing that it does do when it imports, it'll automatically reset that center of gravity to 0, 0, 0. So if I go back to the cluster that we had manipulated, I want to say it was this one. Yes. See, we had changed our center of gravity, but when we import it, it automatically set it to 0, just like if you had clicked this button in the transform window. Now let's go ahead and export this cluster to a CSV file. And we'll call it csv.csv. Yeah, CSV2, whatever. So as soon as that exports, there it is. And then there's our cluster, sphere radius XYZ. So if you were going to create a CSV file and import it into Newton, this is the format you should follow. So you could write your own script or your own program that will generate your clusters for you and spit out a CSV file. And you can go ahead and import the CSV file right back into Newton. So import CSV2, give me a name, and there's our same cluster, same as the one right above it. Now there's a maximum limit on the number of spheres that you can create, and that limit is 2,000. But we recommend the more clusters you have in each of the more spheres you have in each of your clusters, the shorter the required time step for the simulation. So by creating a sphere with a 2,000 by creating a cluster with 2,000 spheres, you're really going to be slowing down the simulation. So we recommend, an upper limit of maybe 2 to 3 to 4 to 500 spheres in your clusters. And if you can avoid using large numbers of spheres, it's usually better. But it's up to you. So now I think that covers everything in this window. And if there's any other questions regarding the cluster creation that's not addressed in the manual, then go ahead and send us an email at info@actek.com. Thanks.